form A equals the integral from alpha to beta of 1/2 r squared d theta, and you would use that for something like this. R equals sine 3 theta, where you want to find just the pedal or the whole thing, depending on your boundaries. Alright, so we have r equals sine 3 theta. Set it equal to 0 to figure out when it intersects with itself, because we're looking for the first pedal. Take the inverse sine and figure out that it equals k pi to 3 theta. Divide by 3 and we know what theta is, and this is our first two intersections at 0, meaning that that's our first pedal. We plug that information all up in here. We get this, and we get sine squared, which we need to use the power reduction on to become this. Simplify a little bit, take the integral, evaluate the integral, and you get pi over 12.
Now to find the area between two polar curves, you have area equals the integral from a to b 1/2 of r squared, r2 squared minus r1 squared d theta. And that'll be used for a problem like this, where you have two polar curves and you want to find like the outside of the pedals like this. For our example, for finding the area between two polar curves, we're going to use the equations r squared equals 6 cosine 2 theta and r equals square root of 3. First step, you have to set them equal to each other. So you have square root of 3 and then square root of 6 cosine 2 theta, because that's r squared. And then you square both sides, you get that, and then you get cosine 2 theta equals 1/2 after dividing by 6. So you take the inverse cosine of both sides, and you get 2 theta equals pi over 3 and 5 pi over 3, and you divide by 2 and get theta equals pi over 6 and 5 pi over 6. So this is what the graph looks like, and we're trying to find the outside of the pedals. And to make it easier, we're just going to go from 0 to pi over 6 to find the first sector of the pedal, and then we're just going to multiply it by 4. So here's our integral set up. We have the 4 times the integral from 0 to pi over 6 of 1/2, 6 cosine 2 theta minus the square root of 3 squared d theta. First we'll simplify, just take the 1/2 out, make it 2 in front, and then we just have 6 cosine 2 theta minus 3 inside. And then take the integral, so you have 2 times 3 sine 2 theta minus 3 theta from 0 to pi over 6. And then plug in the values and add them up, and you get 3 square root of 3 minus pi for the area of between the curves.